We were solving numericals in the last lecture, higher level numericals. And the last question that we came across, that was about springs. And we saw the different conditions of springs. Now let us come back to that question. What it says, a tray of mass 12 kg is supported by two identical springs as shown in the figure. The figure is like this. Here is a tray whose mass is 12 kg. Two springs are supporting that tray, and those two springs are fixed here. So that is the given question. So a tray of mass 12 kg is supported by two identical springs. They are identical springs, means their force constants are equal. Means suppose if this is K1, this is K2. So they are identical springs, means K1 is equal to K2 is equal to K. Right? Further, when the tray is pressed down slightly and released, क्या किया उसने? Tray is pressed down slightly and released. What will happen? It will perform simple harmonic motion. Obviously, is pressed down and slightly released. It executes SHM with period of 1.5 second. The period of SHM is 1.5 second. Okay. What is the force constant of each spring? Means K1 is equal to K2 is equal to what? You have to find the force constant of each spring. When a block of mass capital M kg is placed on the tray, अब आगे की condition, block of mass capital M is placed on that tray, the period of SHM changes to 3 seconds. So this first condition is over. In this condition, mass was 12 kg. Now in second condition, mass is 12 plus capital M, and the periodic time is 3 seconds. What is the mass of the block? You have to find this capital M. This is the complete question. You have to find K. Which relation comes to your mind? The period of SHM T is equal to 2 pi under root M by K, whereas K will be effective force constant of the two springs, because there are two springs and they are in parallel. So K means K effective, right? Square both the sides. T square is 4 pi square M by K effective. We have to find that K. So K effective will be equal to 4 pi square M upon T square. That is equal to 4 pi square approximately. We take it as 10. So 4 into 10, that is 40. Small m, mass of that tray, is given to be 12. And capital T is 1.5. So square of 1.5, that is 2.25. Correct? Now 2.25 can be written as 9 by 4, converting decimals into fractions. So this is 9 by 4. 3 3s are 9, 3 4s are 12, 4 4s are 16, 4s are 64, 640 by 3. So that will be 3 2s are 6, 3 1s are 3 carried 1, 3 3s are 9 carried 1, 3 3s are 9. So effective force constant is 213.3. That is effective force constant, दोनों का मिलके. And since the springs are in parallel, that effective force constant is K1 plus K2, means K plus K, that is 2K. So K means either K1 or K2 will be half of this, isn't it? Because effective force constant is this much, which is K plus K, that is 2K. 2K means this is K, this is K. So K will be K effective by 2. मतलब इसको 2 से डिवाइड करेंगे. 2 1s are 2, 0, 2 6s are 12, carried 1, 2 6s are 12, 2 6s are 12, 106.66. इतना क्या? न्यूटन पर मीटर. Why? Because force constant F equal to kx होता है. So K equal to F by x, Newton per meter. So the unit of force constant is Newton per meter. Of course, this is a approximate value, isn't it? 106.66 Newton per meter is approximate force constant, because in place of pi square we have taken approximate. So your answer is approximate. This actual answer will be near to this. इसके आसपास का आंसर रहेगा, इससे थोड़ा सा कम रहेगा, because we have increased the value of pi square. So this will be little less than 106. That is your first answer. Now you have to find capital M when this is kept here. Again, you can use the same formula. T is equal to 2 pi under root M by K. So now in the second case, again, T is equal to 2 pi under root M by K. But this M will be now 12 plus capital M, because now the total mass will be mass of the tray plus mass of the block. So this M will be 12 plus capital M, and we have to find this capital M. So again, squaring both the sides, T square is equal to 4 pi square into 12 plus M by K, and K is obviously K effective. So 12 plus M is equal to 2T square into K effective upon 4 pi square. That is equal to, T is now 3 seconds. So 3 square is 9 into effective force constant is approximately 213 or 212. You can take, for simplicity's sake, 212 upon 4 pi square, that is 40. So 4 10s are, 4 5s are 20, carried 1, 4 3s are 12. That is equal to 9 3s are 27, carried 2, 9 5s are 45 plus 2, 47 upon 10, or that is 47.7. So 12 plus M is 47.7, means M will be 47.7 minus 12, that is 35.7 what? Kg. So mass of the block is approximately 35.7 kg. Exactly, it is 36 kg. Exact answer is 36 kg, and we got 35.7 kg. So our answer is correct. Two masses, M1 equal to 1 kg and M2 equal to 0.5 kg, are suspended by a weightless spring. Two masses are suspended by weightless spring. M1 and M2 are suspended by the spring of force constant 12.5 Newton per meter. इस स्प्रिंग का फोर्स कांस्टेंट है 12.5 न्यूटन पर मीटर. फाइन. When they are in equilibrium position, ये इक्विलिब्रियम पोजीशन है, मींस द स्प्रिंग इज स्ट्रेच्ड. मास लगाने के बाद स्प्रिंग इज इन द stretched condition and they are in equilibrium, means the weight is equal to the restoring force, means it is not moving, it is not performing any motion, the system is in equilibrium. When they are in equilibrium, M1 is gently removed. Okay, अब ऐसे निकाल नहीं पाएंगे हम, तो ऊपर M2 लगाते हैं, नीचे M1 लगाते हैं. What is done? M1 is gently removed. Calculate the angular frequency and amplitude of M2. When M1 is taken out, there is now only M2. And when you take out M1, that much weight is reduced. So due to that, the spring or the block M2 will start oscillating. Imagine करो, इसको अगर निकाल लो आप, now it is in the stretched condition. Spring stretch हुई है और stationary है. इसको निकाल दो तो weight एकदम से कम हो गया, ये spring ऊपर जाएगी and it will start performing simple harmonic motion. So the spring is performing, or the block M2 is performing simple harmonic motion because of what? Because of reduction in weight of M1. M1 का weight कम होने के कारण it is performing simple harmonic motion, and you have to find the angular frequency and you have to find the amplitude of SHM. So in this case, restoring force F, which is Kx, and T is equal to 2 pi under root M by K. Now, which mass is performing simple harmonic motion? M2 is performing simple harmonic motion. And it is performing simple harmonic motion due to which mass? Due to M1. It is performing simple harmonic motion because of change in weight due to M1. So, this F is equal to Kx. F is mg, correct? And which M? M1 or M2? M1. इसके कारण SHM हो रहा है. So M is M1 is equal to K into X, means here now amplitude. X is the change in length, right, due to reduction in mass, and that is amplitude. जैसे हमने कल देखा था कि suppose ये एक मास बंधा हुआ है, ये इक्विलिब्रियम पोजीशन में है, means it is not performing oscillation. When you pull it down, जितना आप उसको नीचे खींचोगे, that will be the amplitude of SHM. So same here, M1 निकालने के कारण वो जितना ऊपर जाएगा, that will be amplitude of SHM. So X is actually A, amplitude of SHM. So M1 is it given? Yes, M1 is how much? 1 kg, and into G, that is 10, is equal to 12.5 into A. So amplitude will be 10 upon 12.5, or 100 upon 125, 25 fours are 25 fives are, that is equal to 0.8 meter. So the amplitude of SHM is 0.8 meter. What next is asked? और क्या पूछा है उसने क्वेश्चन में? देखो, angular frequency. Angular frequency means omega. And how can you find omega now? You know the value of K. You have to find omega. So K is equal to m omega square. We have seen this in theory in the derivation. Or you can say omega is equal to under root K by m. And which m now? Actually, M2 is performing the simple harmonic motion. So now M will be M2. ये समझ लो अच्छी तरह से. When M1 was removed, the force was acting due to M1. M1 हटने के कारण force act हुआ. Therefore, we took M1G is equal to KA. Now we are finding the frequency. किसकी frequency? Who is oscillating? M2 is oscillating. So we take the mass M2. So omega is equal to under root K is 12.5 upon how much is M2? It is 0.5. 0.5 means 1 by 2. So 12.5 into 2, that is 25, and root 25 is 5. 5 what? radian per second. That is the angular frequency of SHM.